Lecture 3. Today we're going to talk about naming compounds when the first element is a metal but is located in the central part of the periodic table, which we call the transition elements. This includes all the yellow ones except for silver, cadmium, zinc. These have single charges. All of the ones that are in yellow are multivalent, therefore meaning they have more than one possible positive charge available. So today, I just wanted to make sure we talked about the periodic table. You should have one present with you. Yours should also have 1 plus 2 plus 3 plus, 4 plus minus, minus 3, minus 2, minus 1. These are things that you should have labeled on your periodic table. So today, we're going to talk about the ones that are located, which we call multivalent metals, which we use the stock system. Let me make this a little larger. So, same rules. Naming compounds when the first element is a metal, but has more than one charge. These are located in the transition elements, like I said before. These are the transition metals, and this is except for zinc, which is a +2 only, silver +1, cadmium +2. These are the metals of the and the metals of group 13, which is except aluminum, boron, and gallium, they have multiple charges. When these elements are in this ionic compound, we must indicate the charge. There are two systems used to identify the charges. The old system, which we don't do anymore. This is the Us's and the X. They are still out there, but we use the stock system. This is where in the stock system, the charge of the metal is indicated by the use of the Roman numerals in parentheses after the metal name. So Roman numeral 1 means it's +1. Roman numeral 2, +2. Roman numeral 3, +3. IV, +4. V, +5. etc. So we're going to write names for these compounds. So we're going from a chemical formula to a chemical name. And one thing I want you to remember that these compounds were created by we used criss-cross to determine the number of atoms of each of the cations and of the anions. The anions can be polyatomics or they can be nonmetals. So, same rules apply. If it's a poly, we just write that part of its name. If it's an element, we change the ending to "ide." So, first thing I see here is copper. Cu. If you look at your periodic table, and you need to become very familiar with this should be your friend. Copper is in the transition elements. Therefore, because I do not know his charge, I need to write a parenthesis. So I'm going to write copper, parentheses, because I do not know it yet, and I cover up the copper, and I see that it has OH. This compound has more than 3 elements, therefore I have a polyatomic. I look it up on the back, and it's hydroxide. Now, I'm not finished until I can tell you what the charge of this copper is. I know this copper was formed by crisscross. I can uncrisscross. I see that I have 1 here, so therefore I have a +1 here. It's going back this way. Copper has a 1, therefore it's going back this way. Copper has a plus, OH has a minus. Therefore, the charge of this one copper, because I only have 1 of them, this positive charge, this has to be written inside the parentheses, indicating it in this compound that copper has a +1 charge. Compound 2, I see that I have Cu again. Just as we discussed, this is in a transition element. It has multiple charges, so I'm going to write its name. Add the parentheses, because I do not know at this moment what copper's charge is. I look at hydroxide. I see OH. That's going to write hydroxide. I can also uncrisscross. This 2 originally came from the copper. The 1 came from the hydroxide, and I know hydroxide's charge is a -1. So I have a +2 here and a -2 here. It equals 0. So I can, now I know the copper in this compound's charge is a +2. So I'm going to put that Roman numeral 2 to indicate that copper has a +2 charge. Uncrisscrossing doesn't always work, but most of the time it will. So now, third compound, I have Pb. Pb is, looking on my periodic table, when I look for Pb, I find it located here. It is colored yellow. It is in the wrong column to be transition, but this 6 or these 6 act like transition elements. They have multiple charges. Therefore, I must use parentheses and determine what their charge is. Pb is lead. I do not know its charge at this moment. I see that Cl, I have chlorine. That means I have chloride. Remember when I changed the ending of the element to I? And I can uncrisscross. The 2 originally came from the lead, the 1 going this way for the chlorine, which I agree with. Chlorine has a -1 charge, so I have no problem with lead being a +2. So I am going to put its charge +2 as a Roman numeral inside that parentheses. It's telling me the charge of lead is +2 in this compound. Next compound is still PbCl. Now it's Cl4. So I know already by the previous one that Pb is lead. Put an empty parentheses. I see that it's binary. So the Cl is chlorine. So I'm going to write chloride. Remember, change the ending. Uncrisscross, this 4 is coming up top. This 1 from lead is coming up here. So a +4 and a -4 gives me 0. So this compound is lead, Roman numeral 4, based on this charge. This Roman numeral tells me about the charge of the lead, its oxidation number. Okay, as we move on, I have Hg2, NO3, 2. Hg is mercury. It is transition, therefore I use parentheses. Hg is, like I said, is mercury. Mercury something, because I don't know. And I see that this is more than 2 elements. NO3 is a polyatomic. I look it up. NO3 is nitrate. Okay, now I can uncrisscross. This 2 comes here, this 2 comes here. Because of these 2's, both of them are 2's, I can reduce. This is an exception. So this is mercury. 2 into 2 gives me 1. This is mercury 1. It is diatomic, meaning it likes to have 2 of them in the compound. This will never be on the test. I like to show you some of the exceptions just so that you be aware. You will possibly see these on homeworks, but not test. I do not test those. Next guy, Hg is also mercury. Parentheses, because I do not know its charge automatically because he is transition. NO3 is also nitrate. In this case, I see that this 2 came from this mercury. I have 1 mercury here, -1. So a +2 and a -2. Therefore, this mercury is mercury 2 nitrate. Mercury 1 is my exception. Diatomic. Comes in pairs. Mercury 2 does not. So, next one, Cr. Cr, looking on my periodic table again, when I look around, oh, Cr is element 24, and I see that it's transition, therefore I need a parenthesis. So I write chromium's name, put a empty parenthesis. I see when I cover up the Cr that is a single element. Therefore S, looking on my periodic table, is sulfur. Changes ending to sulfide. Element endings change to ide. Polyatomic's name stays the same. So sulfur is under oxygen. It has a -2 charge in that group. So I have one of those. If I have one of those, this has to, I can't back up. If I uncrisscross, there's a 1 here. There is a 1 here. But when I look up sulfur's charge, it is not a -1. It is a -2. What times 2 will give me a +2. So therefore, this is also a 2. Uncrisscrossing doesn't always work. This would have been something that would have been reduced if I was going from a chemical formula to a chemical name. So this 2 will be written here. So one way I can check this, I can go backwards. I can look at my name and say, okay, I have chromium, Cr, +2. That tells me about my chromium. Sulfide is sulfur, -2, crisscross. This 2 would come here, this 2 would come here. I must reduce. Therefore, my final answer is CRS. Now, your name should, if you go backwards, you can check yourself, should come up with the same chemical formula that you started with. If not, there is something wrong in your process. That's kind of like an internal check. So I'm using the anions to determine the charge of the cation. This example here, we still have chromium. Just by looking at it, I cannot tell, so I'm going to put my empty parentheses. S is sulfur, which is sulfide. With this one, I can uncrisscross. This 3 was originally with the chromium. I'm uncrisscrossing it. The subscript is becoming superscripts. This 2 is a -2. Sulfur's charge is -2. Therefore, this chromium, these chromiums are +3. +3 times 2 is a +6. -2 times 3 is a -6. This compound is 0. Therefore, this Roman numeral charge is 3. I can do the same thing. Chromium is Cr. S is symbol is S. It says this guy is talking here. Therefore, I put a +3 on top. Sulfur, I know from where it's located on the periodic table. Crisscross, I get Cr2S3. I recaptured my original compound. Therefore, I know I'm right. It's a way that you can double check. This is going from symbols to names. Chemical symbols to chemical names. What you do one way, you can undo. So remember, you can undo crisscross to find charges for most of the compounds. Now we need to go from giving you chemical names to writing chemical formulas. So you need your periodic table and your polyatomic chart. They should be with you all times. Those are your BFFs that you will be using the whole year. So you might as well make them your friend. They will help you through this. So I look at the first one, and remember, we still do crisscross. These are metals. The only thing I don't do crisscross is nonmetals, bonding with nonmetals. So 10. So looking at my periodic table, and I know where it's located. Some of you are new at this, and you should be letting your fingers do the walking and trying to get familiarized with the map. So once you start figuring out where things are, the more you work with this chart, the better you get. SN is 10. So I'm going to write 10 symbol right here. And I see this Roman numeral followed by 10. And based on its location, I know it should have a Roman numeral that tells me the charge of that element in this compound. IV is 4. So I'm going to put a +4 on top, my superscript. And fluoride, there's my clue for, can't spell today, for element. And when I see ide, so fluoride is fluorine, so this is F. And I see that it's in the halogens, which has a -1 charge. Crisscross. So my final answer is SNF4. This is a +4, this is a -4, therefore it is a net charge of 0. Okay, next compound. I see I have silver. Oh, I have a hint here, no parentheses. That means this has a single charge. And if I look on my periodic table, this is something you were supposed to memorize. We put it in ours so that you wouldn't forget. So silver always has a +1. Therefore, I do not have to use parentheses with silver. Hence, it's not silver 1. So silver is Ag +1. Nitrate, this ending, ATE, tells me it's a polyatomic, which I can look and find it. There it is, NO3 -1. Crisscross, the ones come. Because they're ones, I do not need to show them. I do not need parentheses, so my final answer is AgNO3. Next compound, I see iron. Iron 3 oxide. So iron, element 26, is located in the transitions. Therefore, it must give me a Roman numeral to tell me the charge of this iron. So I have Fe is talking plus 3. Oxide is element, oxygen. And I know based on its periodic table where its location, -2. Crisscross, this 2 comes here, this 3 comes here. So when I rewrite this, this is Fe2O3. Now, I can do the same thing. If I wanted to, I know Fe is iron. And I know based on my periodic table, E needs a parenthesis. And O is oxygen, change this ending to oxide. I need to figure out the charge of this iron. In this compound, I can uncrisscross. Therefore, this 3 becomes a +3. This 2 becomes a -2. And I can put a Roman numeral 3. So I have checked my work, and I have come up with exactly the same thing I started with. So I know Fe2 Fe2O3 is my compound. This is an internal check that you can do anytime. All right, mercury 1. Remember, my mercury 1s are diatomic. I will never use this on a test. Mercury is Hg, and in this case it says +1. Mercury is right there, transition. Transition, I have its charge. Bromide is an element, Br. And remember, mercury 1 is diatomic. If I crisscross, this is a 1, this is a 1. Because it's diatomic, I must put Hg2, therefore I have Br2. Okay. Nickel 2 sulfate. Nickel. This is telling me he's transition. Nickel is transition, so I do not know his charge. They told me his charge. It's required in a name. Nickel is Ni, has a +2 charge. Sulfate is a polyatomic. Sulfate. So this is one of those things you have to get used to. This is more common. You will eventually remember this. SO4 -2, remember, the only time you do not get to use this is when you have the elements and the polyatomic test. After that, you will always have this chart on your test. So, sulfate, SO4 -2, crisscross. And the kids usually say applesauce, so I'm going to take this 2 and put it there. This 2 here. I have 2's and 2's. Therefore, I must reduce. Just like in math, 2 divided by 4 is 1/2. Your teacher would be kind of upset with you if you wrote 2/4. Must get the lowest combination. Because I am reducing, I will no longer need the parentheses. So my final answer is NiSO4. If I wanted to double check, Ni is nickel. I do not know, I can't spell today. NiCkel. I do not know its charge. SO4 is sulfate. So I know sulfate, if I uncrisscross, this is a 1 and this is a 1. But sulfate has a -2 charge. Since I have 1 nickel, I must have, this guy must be a +2. Therefore, I would put a Roman numeral 2 inside my parentheses. I have now checked my answer. It is correct. I just want to reiterate, I hope y'all been studying for your polyatomic and your element test. You will have to spell these correctly. You must, for the polyatomics, also give the correct charge that's indicated. If I say nitrite, you must write NO2 minus 1. NO2 without the charge is not nitrite. I hope you're preparing. That test will be soon. Thank you.